This digital tutor is going to talk about constrained resources and the strategies we need to use. A constraint is when you can't get enough inputs, materials, labor, how many hours you can run your machine, how many deliveries you can make, and so forth. And typically this constraint is short term because if you have a lot of market demand, then you'll get another truck or another machine or hire some more workers. But in the short term, this may be a constraint you have to work with, that you only have 24 hours a day or so many hours of machine time, or there may have been a freeze in Florida and you can't get oranges in the short term until you can negotiate a contract to get them from California and so forth. Okay, so how do we approach these problems? Let's have a look. First, let's figure out if we have a constraint at all. Here's a beverage manufacturer that makes 4 kinds of beverages, all of which use their mixing machines, and they only have 14,400 mixing minutes available per month. So are they going to be able to satisfy the full market demand or not? All right, freeze the frame, see if you can think through this, and then we'll discuss the answer together. So what I have done is figured out, all right, how many mixing minutes will it take me to meet the demand for each of the 4 products? And then I can add them up. Oh, to make all of them, I would need 15,900 minutes, and I only have 14,400, so I do have a constraint. All right, so now we need a strategy. Our strategy is going to be to figure out which product generates the most profit, not per unit, because we can't make all the units that the market would like us to make, but profit per minute, because the minute is what's constrained. And so we'll make whatever gives us the most profit per minute first until we satisfy that market demand, and then we'll go to whichever one has the next best profit per minute and continue until we run out of minutes. Let's have a look and see how this will work. All right, here's my contribution margin per unit. Freeze the frame and see if you can do the contribution margin per minute. Okay, so you're not going to make 280 per minute because each unit takes 2.2 minutes. So you have to divide the 280 by the 2.2 to get the $1.27 per minute. All right, freeze the frame then and see what order you would produce them in. Full makes the most per minute. So we're going to satisfy market demand for that first, and we're going to use 1,700 minutes, and then we'll have 12,700 left. What's next? So we'll make Buzz next, and that's going to use 7,200 minutes, leaving us with 5,500. So after that, we'll use Chunky, and actually we can satisfy the full market for Chunky, and then we'll have 700 left. So how many units of light can you make with 700? Freeze your frame, see if you can work it. That's right, each of those is going to use 2.2, so you divide your remaining 700 minutes by your 2.2 and you get your 318 units of light. And now you're out of minutes. Okay, here's the new problem. Freeze your frame and figure out if you have a constraint. Yep, you have a constraint. You need 5,150 minutes and you only have 1,440. Boy, you sure need to buy a lot more ovens if this is a stable demand, right? Okay, let's finish then. Come up with a production recommendation. Freeze your frame, see how far you can get. All right, here's your contribution margin per cake, but we have a constraint, so we need the contribution margin per minute of oven time. Okay, freeze your frame, see if you can finish. I got you this far. So you would satisfy the demand for lemon cakes, and then you would make as many white cakes as you had oven time left over. Here's another one. Freeze your frame and work it, and then we'll discuss it together. So we can only make so many deliveries per day, and if we take our contribution margin per delivery or per load, we get our contribution margin per day for each of these. You could also do it per week. You wouldn't get a different ranking. And we see that chips is the most profitable, so we'll start by satisfying the demand for chips and see what we have left over. As it turns out, it uses all 100 loads per week just to satisfy the chip demand. So until we have more trucks, we ought to be just doing chips. Okay, here's your last one, and I've shown you what a multiple choice format might look like. Freeze your frame and work this one. So here you have my computation of the contribution margin per pound and then per hour, and then I have ordered them 1 through 4, and now I have satisfied the demand for raw, and then I go and satisfy the demand for grit. I still have some hours left over, and I'm going to use the remaining hours on color, and I'm only going to be able to do 833 pounds of color. All right, freeze your frame and try to write out an answer to this. We want to compute the contribution margin per unit of resource and produce in that order. While contribution margin per unit tells you the profits per unit, it doesn't help you if you run out of your inputs and can't produce those units at all. You have now studied relevant costs with a constraint input. Keep practicing and refreshing.